Hi, this is Professor Evans. This video is for the students of COP 3330C, which is Object-Oriented Programming for Valencia College in Orlando, Florida. And this first video is going to go over classes and objects. We're going to be using Java and IntelliJ for this video. The learning outcomes for this video and the subsequent assignments are that students will be able to develop a simple program using the principles behind object-oriented programming and to be able to implement a program using classes and objects. Whoops. So a few notes before I begin. This is a tutorial to go along with the other resources that are provided online. Please watch this video after you have completed the reading provided on Canvas. This includes reading through the textbook and any online articles that might have been posted. I am going to go over a few of the key words and phrases that you will need to be familiar with in order to go through this video, but it's probably best if you do the reading first before you walk through this video. Once I get started with the actual demonstration, please open your IDE and write the code that you see on the screen along with me. This is the best way to learn and capture the information that you're seeing is by actually going along and writing the code with me. Once you're done, you'll be able to use that code and this tutorial as a resource when you're working on your programming project for this module, as well as preparing for any future exams. So before I get started, I'm just going to go over a few basic definitions. These are the definitions that you should have seen in the reading that was provided online. So just to recap, a class in Java is like a blueprint. It defines the type of object you're going to create, and that includes the attributes, or another word is fields, that the object will have, and any actions, which are going to be your methods, that that object can perform. It's like a template. Once I create a class, I can create as many objects using that class as I want to, and each object can have different settings within the attributes. For example, I could have a class of shapes, and I could have a different area depending on the type of shape. An object is an instance of a class. It's like taking that blueprint and bringing it to life and supplying data in the attributes or fields that we can then use whenever we perform the actions or methods on that object. So it's taking your blueprint or your class and bringing it to life. A method is a block of code within a class that performs a specific task, similar to what we would call a function in C or C++, and it belongs to that particular class. Instantiation is the word we use when we're actually in our IDE and we're creating a new object from a class. So later on in this video, I'll point out exactly when the instantiation occurs, but that's our process or our keyword for when we're actually creating that new object from a class that has been written. I believe I already covered this, but attributes or fields are properties that the object or the class have. And then your UML diagram is a visual representation of a class showing the attributes and the methods. It also describes the visibility of those attributes and methods, whether they're public or private. And then it also indicates the data type or return type of whatever's being presented within the diagram. It's a great way to understand the structure of a class at a glance. So today, I'm going to do an example of classes and objects using the TV show The Office. That's going to be my inspiration for this example. So overall, we're going to have 4 classes that we're going to create. The first one is going to be the Salesperson class. And the basic objective of this class is to make sales and record them. We're going to have a warehouse class that has to monitor the supply of paper within the warehouse. And then we're going to have an office manager class. The office manager schedules meetings and wastes time. If you've never seen the TV show The Office, these are 3 components of some of the characters on the show. It's about a paper company in Scranton, Pennsylvania that is in the business of selling paper, and some of the characters fall into one of these 3 classes. You don't have to know the show to understand what's going to happen next, but if you've seen the show, or if you research what the show is about, you'll see how the show inspired our conversation today on classes and objects. The last class we're going to write is called the Office app. Our app class is just going to have one main method, and that main method is sort of the driver to instantiate each of our classes, call their methods, and then print out information about each object that we have created. So these are the 4 classes that you're going to see me write code for in just a few minutes. Before we do that, here are the UML diagrams for our 3 classes. So once again, within our paper company, we have a salesperson, we have the warehouse, and we have the office manager. These are just 3 of many roles that you might identify within a typical company. With the salesperson, we are going to declare the attributes in our first box. So the very top box is the name of the class. The first box below that are the attributes. For every salesperson that we create, we want to know their name, their sales figure, meaning how much money have they sold this year, and then the number of reams of paper they have sold. So we have these 3 attributes, and notice that we begin with a dash here. This is actually like a minus sign, and it represents that these attributes are private, meaning they can only be accessed by methods within the class. So for example, the warehouse class is not going to be able to change the values of a salesperson's name, sales figure, or reams sold if these are identified as private. So we have these private attributes, meaning that only the methods that are described down here can modify these attributes of our salesperson object. So below here, these are all the methods that we're going to write for our salesperson class. The first 2 methods are constructors. Constructors are required whenever you instantiate a class. A constructor allows you to set initial values. So for example, if I know the name, sales figure, and reams sold for a particular salesperson, when I create that object, I can supply that information here, and that object will have that data. If I don't know the name, sales figure, or reams sold, or I want to have a default setting for a salesperson, I can create a second constructor that doesn't take in any arguments, and it will set the values to a default value that you pick as the programmer. You'll see more about that later when I start writing the code for this. After our constructors, we're going to have our get and set methods for every attribute in your class. This class has 3 attributes. That means I'm going to have 3 get methods and 3 set methods that will allow us to access the values stored in each one of these attributes, or allow us to change the value stored in any one of these attributes. So a get method will just return the value of that particular attribute. So we have get name, get sales figure, get reams sold. These 3 methods are just going to return the value of whatever is stored in these attributes. So we can see after the colon, there is a return type. Get name is going to return a string because the name is defined as a string. Get sales figure is going to return as a double because it has been defined as a double. Get reams sold is going to return an int because it's been defined as an int. So those are our get methods. Then we have our set methods. This allows us to change the value stored in any one of these attributes. So set name will allow me to change the name. I can supply a new name right here. Once I supply that new name, this method will change whatever name was previously stored to the new name, whatever is supplied as an argument to this method. So this method has an argument where we have to supply what we want the new value to be, and its return type is void. It's not returning anything, it's just changing the value of one of our attributes. So we have our set name, set sales figure, and set reams sold methods that will allow us to change the value of these attributes. So whenever we're creating a class, we typically are going to start by defining our attributes, defining our constructors, and then defining our get and set methods. So this UML diagram walks us through all of that. After that, you'll write any custom methods you want for that particular class. In this case, we want the salesperson to make sales, and we want to record their sales. So we're going to have a method called increase sales. We're going to supply the amount of reams sold and the price that they were charged in order to increase the sales. So within this method, we're going to be updating the sales figure and reams sold to reflect that a sale was made. Lastly, we're going to have a print details method. It's void. It's just going to print out a message about this particular object to the screen. So let's say at any point in time, I want to know what the name, sales figure, and reams sold is for a particular salesperson object. print details is going to just print all of that out for me. Next, we have our warehouse class. And the warehouse class is just going to monitor the supply of paper. That's it. Every time a sale is made, we want to make sure that we decrease the supply to reflect that some paper has now been sold. So we have one attribute called paper supply, and it's going to be an integer representing the number of reams of paper available in the warehouse at any point in time. We have two constructors for warehouse, one where we can initiate the paper supply with an argument, and one where we don't have an argument, in which case it'll be set to a default value that we get to choose as the programmer. We have our get paper supply and set paper supply methods, and then we have our custom method. This method, update paper supply, is basically going to update the amount of paper available whenever this method is called. So let's say that a salesman sells 10 reams of paper. Well, we're going to call the update paper supply method. We're going to send in the number 10, and this method is going to decrease our total paper supply by 10. That's the purpose of the update paper supply method. So that's going to be our warehouse class. Our last class is the office manager class. The office manager has two attributes, name and time wasted. If you haven't seen the show, The Office, the manager on that show is a big time waster. It's part of the comedy of the show, so that is why that attribute is included here. And the office manager is going to have the get name and set name methods, our get time and set time methods, our constructors, and then our custom method for our office manager is that the office manager will organize a meeting provided the reason and location are given. And then lastly, we have another print details method for our office manager. That print details method is just going to let us know the manager's name and how much time they have wasted so far. So our UML diagrams give us a roadmap for each method we need to create, what the return type of the method should be, and whether those methods are public or private. In this case, I've made all of these methods public. That's because I want to be able to call them from another class. Our main class is going to be calling some of these methods in order to print information out to the screen so that the user can see whether a sale has been made or whether a meeting has been called or anything like that. So we want the methods to be public, and we do that by setting them with a plus symbol here to signify that this method can be called by another class. So if the warehouse class or the salesperson class or the office manager class has a public method, that means those methods can be accessed by another class. So I suggest you take a quick screenshot of this UML diagram so that you can reflect back on it as we begin writing the code for each of our three classes. So I'll give you a second to do that, and then I'm going to switch over to IntelliJ. All right, so now I am going to start going through each one of the classes that we need to create. So you'll want to go into IntelliJ and create a new project if you haven't already. And within the source folder, I'm going to create 4 classes. The first one I'm going to call Salesperson. The second one I'm going to call Warehouse. The third one I'm going to call Office Manager. And the fourth one is going to be our app that is going to instantiate these classes. So I'm going to call that Office App. And then let's begin with the Salesperson class. When you write a class, it's best to begin with a comment at the top that explains what the class is supposed to do. So this is our salesperson class. It represents a salesperson in the office. Salesperson is able to make and record sales. It's the purpose of our class. Within our class, the first thing that we're going to start with are the attributes. If you go back to our UML diagram, our attributes were name, sales figure, and reams sold. So these are our 3 attributes that we're going to add here. Notice that they're all private. Then they all have a data type and then a name. Once we have our attributes, we're going to move on to our constructor. We want our constructor to be public because it's going to be accessed by our main method in officeapp.java. Our constructor always has to have the exact same name as the class. That is one of the rules of creating an constructor. So our constructor is going to take in name, sales figure, and reams sold. And we're going to use the this keyword to assign values. I want you to notice 2 things. Number 1, I have my attributes called name, sales figure, and reams sold. And then I gave the arguments of my constructor the same names. Even though these are the same names, they don't represent the same piece of data. Notice that this is purple. The purple in IntelliJ lets you know that you are referring to an attribute of a class. This is white. This is letting you know that you're referring to an argument called for this method. So when I type in these statements right here, what I'm saying is take whatever string value was supplied for the method attribute name and store it in the class attribute called name. I could call this anything I want. If it makes more sense to you to slightly change this, for example, I could say the name and the name. That way I can see that whatever I'm passing in here to the method is right here, and it's being assigned to the instance attribute value name right here. Conventionally, we usually just use the same name as the attribute, but I just want to point out that they are different values. Another thing in IntelliJ that's nice is it's constantly compiling for you. So for example, if you see a red squiggly line, you know that something's not right. I'm missing a comma right there. So you can hover over the red squiggly lines to try to figure out what the error might be. So here's our first constructor. I'm going to make a second constructor, and this is called creating an overloaded constructor. I'm going to give you a definition of overloading. So an overloaded constructor in Java is a concept where a class has more than one constructor, each having a different number of parameters or different types of parameters. So depending on how I'm going to use this object, I might want to have different ways of creating it for the very first time. I might want to assign name, sales figure, and reams sold all at once. Maybe I only want to assign the name. Maybe I want to have default values if I'm not sure what the name, sales figure, or reams sold would be. So you can have multiple constructors. And what makes them overloaded is that you just have different parameters or different types of parameters within your declaration of that constructor. So my second overloaded constructor is going to be one in which I don't really know what my attributes are going to be. I just want to have some default values. So I'm going to give it the exact same name as before, but this time I'm not going to supply any arguments. Now I'm creating a second constructor and I'm now overloading. Let's say that I'm not sure what the name is going to be and I just want to have a default name ready to go. So if I create my salesperson class and I'm not sure what the name, sales figure, and reams are that are going to be assigned here, I'm going to use this constructor instead. So this is the second option I have when creating or instantiating this salesperson class to create an object. You'll see more how this works when we get to our Office App Java class. Next, we're going to have our get and set methods. So for example, I have an attribute called name. I need a get and set method for name. Here's my get method. The get method just returns the value of name. Since name is a string, I have to declare this method with a return type of string. And I'm going to make it public so that other classes can access this method. That's the whole point of this method. By making these attributes private, the only methods that can actually access the values stored here are going to be your get and set methods. There'll be no other way to access the values, or let's say you wanted to print out a salesperson's name. This being private means that only the classes within this, only the methods within this class are able to access that value. Your main method won't be able to access name. So in order to give the main method an opportunity to know what the name is and print it out, we're going to write a method to do that, and that's your get method. And your set method allows you to assign a new value to name. Again, notice the difference between the white name and the purple name. This is telling you that the value passed in is what is stored here and transferred to your attribute. So I'm going to repeat our getters and setters for the other attributes. We have sales figure and reams sold. So you're also going to want to create your getter and setter methods for those as well. So for example, there's my get method for sales figure. There's my set method for sales figure. And I'm going to do the same thing for reams sold. So we have public int get reams sold. Because reams is an integer, we have to describe the return type as integer here. And then we're just returning our attribute. And then we have our set reams sold, which again will set the value of this attribute to whatever value is supplied right here as an argument to this method. Now we're going to add our custom methods. So custom methods are whatever this specific class is going to perform. So for example, this is a salesperson class, and I want to be able to increase sales or record when a sale has happened. That's what I want to do. So I'm going to write a method to do that. So here's my method. I want to take in as an argument the amount of reams sold. So if a salesperson makes a sale, how many reams did they sell? And what was the price? Once I have those two values, I can update the reams sold by adding the amount of reams provided as the argument. And I can update the sales figure by adding the amount of reams times the price of the reams. So increased sales will allow me to record a sale by updating the amount of reams sold for that particular salesperson and updating their total sales figure, or the total amount of money in sales they've performed, by adding the amount of reams multiplied by the price. The last method that we want to add here is our print details method, which will allow us to see a quick view of the attributes of this particular salesperson object. So I'm going to use a system.out.println line statement to just print to the screen. I want to print their name. I want to print their sales figure. And I want to print total reams sold. So that's what I want to print out, and I just need to encapsulate that within a method. So I'm going to have public void as the name of my method, and I'm going to call it print details. And then within print details, I'm just going to have this statement here to print out the details of each attribute. And there's my print method. So my salesperson class is complete. Before moving on, make sure that you don't have any red squiggly lines underneath your file name up here or on any line of the code. If so, that means you might have missed something. Try to go back and identify the error before you continue. Once you have that complete, we're going to move on to the warehouse class. Let's add a comment at the top. This class will track the supply of paper reams in the warehouse. If you refer back to our UML diagram, we had one attribute, which we're going to call paper supply. So that's our attribute, and it's just going to keep track of how many reams of paper are in the warehouse. Next, we're going to add our constructor. This constructor will allow us to set a default value of the paper supply when the object is created. I can have a second overloaded constructor. If I don't know what the value that is going to be used here as the initial paper supply, if I don't have an initial value and I just want to have a default value that will always be used, I can set that as well. Let's say that I want to have a default value of 10,000 reams. Next, we're going to do our getters and setters, just like we did before. So we're going to have get paper supply, where we return the value of paper supply. We're going to have set paper supply, where we're allowed to change the value of paper supply. And lastly, we're going to need to update the paper supply. So we're going to have a method called update paper supply. Its purpose is that when paper is sold, we must update the amount of supply available. So we're going to decrease our available supply by the amount supplied here in the argument. So if 1,000 reams are sold, we'll call this method where we'll pass in the number 1,000, and our attribute, paper supply, will decrease by that value supplied as an argument to the method. The last thing I'm going to do is just include a little print line statement here so that the user knows that the supply has been changed. Now, I want to point out something right here. If I were to leave this statement just like this statement is going to print out the value of paper supply, but what value is that? Notice it's white. This is white. If I run this the way it is right now, this print line statement is going to say the current paper supply is, and then it'll print out the value that was supplied as an argument. Remember, in our earlier example, if we sold 1,000 reams of paper, the number 1,000 is what's going to be passed in here as an argument. But I don't want to print out the number 1,000. I want to print out the remaining paper left. That is supplied here in our attribute. So I want to make sure that I use the this operator so that I'm accessing the attribute called paper supply, not the argument called paper supply that was passed into this method. Again, if that's confusing while you're learning and you're practicing these concepts, feel free to slightly alter this name. You could call it the paper supply and the paper supply, just so that you can see the difference between the two if that's confusing for you. Eventually, you'll want to follow this convention though, because this is a standard convention for how we create methods like this. And lastly, I'm just going to add the unit. So the paper supply is in reams of paper. So I'm going to add a unit right there. So this will print out the current paper supply and notify the user that it's in reams. So now we have our warehouse class. Before moving forward, make sure that you have no red squiggly lines anywhere, no errors anywhere. And then we're going to move on to the office manager class. So in this class, we're going to represent, the office manager who calls meetings and wastes time. That's the office manager's function. So we're going to have two attributes for our office manager. Our office manager is going to have a name and the amount of time the manager wastes. And this is like a running total of time. So now we're going to write our constructor. There's our constructor. I'm not going to do an overloaded constructor here because those are just examples and you don't necessarily need to have an overloaded constructor all of the time. It depends on your application. But I am going to go ahead and do our set and get methods for the name and time wasted. All right, so we have our getters and setters for get name, which returns the name, set name, which changes the value of name, get time wasted, which will return time wasted, and set time wasted, which will change the value of time wasted. Now we're going to add our custom methods. So our first one is we want to display a message with the meeting's purpose and location. So I'm going to call this public void organized meeting, where we're going to have as arguments the meeting reason and meeting location. And this is just going to print a message. So we're just going to print a message that says the name for the manager is organizing a meeting for, and then we're going to list the reason and then we'll list the location. And then we're going to add a period to the sentence as well. There's our organized meeting, and then we're also going to have a print details method. It's just going to print out the details about the manager. So we're going to make it void. So our print details method is going to print out the office manager's name and indicate how much time the manager has wasted this year. That is our office manager class. So if you go back to our UML diagram, we've now implemented each method and attribute in each of the classes that were described. Our final step now is to instantiate each of these and watch our methods run. So our office app.java is going to do just that. So in our office app class, we're going to have public static void main. Okay, so we're always going to set up our main class with this declaration exactly in this way each time. And then we're going to start instantiating objects. So let's say my first salesperson, I'm going to name the object Jim. So Jim is now the name of this object. The object's type is of the salesperson class. So when I declare, for example, if I say int value, I am defining a that's a bad word. Let's see. Let me change this to area. I'm defining a value called area. That's the name of the value, and I'm telling you that its type is integer. Same thing is happening here. I'm declaring a value. The name of the value is called Jim, and its type is salesperson. That means that Jim has these 3 attributes. I can call these 2 constructors. I can use any of these getters and setters, and I can call either of these methods related to Jim because I'm naming Jim. I'm declaring that Jim is of type salesperson. Now, in order to instantiate the object, I have to call a constructor. And I have to use the word new to create a new object. So I'm going to call my constructor, and I'm going to call the first constructor, where I am going to tell the object what the name, sales figure, and reams sold are. So this object, once created, will have a name, it'll have a sales figure, and it'll have the reams sold, and I get to pick it by using this constructor. Let's say that I have a second salesperson named Dwight. I'm going to create a second object for salesperson. So these 2 objects have the same attributes and have the same methods, but they're going to have different data. So this salesperson is going to be called Dwight. The sales figures for Dwight are 2,500, and he's sold 752 reams so far. Now let's say I have a third salesperson, and I don't know what the attributes are going to be. This is where I can call that second constructor. So I did not say the name, the sales figure, or the reams sold. But by using this constructor, this object that I'm creating using this constructor will get these values by default. And any other object that I create, if I use this constructor, will get these values by default. So I can create 10 more salesperson objects. I can name them whatever I want right here. But if I use this constructor, then the attributes are going to be these attributes by default. So these are my 3 salespeople. I'm going to create an office manager. And I'm going to supply a name. And the amount of time wasted so far this year, this is minutes. And then I'm going to create a warehouse. And I'm going to indicate our initial value for paper supply. So I've instantiated 3 salesperson objects named Jim, Dwight, and Ryan. 2 of those objects I supplied the initial data for. The third object is the default data in that overloaded constructor. I created 1 office manager. It's called Michael, and its name is set to Michael, and the time wasted is set to 754.54 minutes. And I've created a warehouse called Scranton Warehouse. The warehouse currently has a supply of 125,000 reams of paper. Now let's use some of the methods we created. If Jim makes a sale, I am going to call the increase sales method, but I have to make sure that I indicate which object I'm calling and use the dot operator to access its method. So Jim.increase sales. Let's say that Jim sells 1,500 reams of paper at $29.95 each. I want Jim's object to now be updated with these additional reams and the sales figure to be updated for the amount of money made by selling these reams at this price. So when I run this, I want to eventually print out Jim's information using our print details method, and I want to make sure that the amount of reams has gone up by 1,500 and that his sales figure has increased as well. That's what we're going to be looking for. Next, let's say that Dwight makes some sales. And let's say that Dwight has sold 700 reams of paper and the price was $24.55. That's how we can update the object for Dwight. Remember that we also want to update the warehouse supply whenever some paper is sold. So perhaps after Jim makes a sale, we want to let the warehouse know to update the paper supply. Well, how much paper did Jim sell? He sold 1,500 reams. So we want to make sure that we update the supply. After Dwight sold, we also want to update the warehouse to let it know Dwight sold 700 reams. Now remember, we added a little system.out.println statement within this method, so we should see the warehouse send us a message to let us know that the paper supply has been updated after each one of these sales occur. Now, let's say that Michael decides to organize a meeting. Let's say that the purpose of the meeting is conflict resolution, and that it's going to be in the conference room. Lastly, let's say that Michael wastes, let's say he wastes 1,505.34 minutes preparing for this conflict resolution meeting that he scheduled. So we're going to access the time wasted attribute of Michael by using the set time wasted method. I can't just say Michael dot time wasted. That's not going to work. I can't just say time wasted equals 1505.3. I can't do that because time wasted has not been declared anywhere in this class. The only way to access time wasted is to access the object Michael, because that object is of this type. That object has an attribute called time wasted. That's the only way we can access it. So in order to change time wasted, we have to call the set time wasted value or method. Now let's print out some details. We're going to print out the details for Jim. We're going to print out the details for Dwight. We're going to print out the details for Ryan. Notice we didn't do anything with Ryan's object. So whatever Ryan was instantiated with is all that's going to be there because we didn't actually do anything to Ryan's object. We're going to look at Michael. And we need to see the supply in the warehouse. So in order to do that, we got to call the get paper supply method from the Scranton warehouse object. That's going to return the current amount of paper after we made some sales here and here. All right, our main method is now complete, and we are going to run this and watch our objects interact with the data that we have supplied. So when you're ready, go ahead and hit run. It takes a minute to build. And here's my terminal with my output. So let's look at the first line. The current paper supply is 123,500 reams. Well, where did that come from? When we created the warehouse object, we said that the initial value of paper was 125,000. Then Jim made a sale. And then we updated the paper supply. And there's our message from the warehouse object within the update paper supply method. There's that message. So the message that was called right here is now being printed out. We update the supply again after Dwight makes a sale. And we can see the supply has changed again. Next, Michael scheduled a meeting, and we get a notification that Michael is organizing a meeting for conflict resolution in the conference room. And then we print our details. So we can see Jim has a sales figure of $45,925, and he sold a total of 2,000 reams. When we created the Jim object, we said that he had initially already sold 500 reams. And then when we increased the sales, he sold 1,500 more. So now we see that he has 2,000 reams sold total. With Dwight, initially Dwight had 752 reams sold. He sold 700 more, and we can see the reams sold have been updated, as well as the sales figures with the amount of money earned from those sales. Next, we can see Ryan. Sales 0, total reams 0. We never updated Ryan here using any of the methods. And so the value that is in the Ryan object is whatever was there when it was instantiated. And when we instantiated it using the overloaded constructor, these are the values that were set. So I could change this. I could say that the initial sales figure is $10.50 and the initial ream sold is 5. So if I were to run this again, I'll now see that the Ryan object has different values. $10.5 and 5. Lastly, office manager Michael has wasted 1,505.34 minutes this year. Again, that's because we changed the value of Michael's time wasted right here. We didn't add to what was there before, we changed it. We didn't write a method to add to it. So if I wanted to add to it, I would need to go back and write a method that would increment the time wasted. This is just changing the value. Lastly, the warehouse has, and here's where we call the get paper supply method to get the current number of reams for the warehouse, and it's going to print that out right there. So that's the end of the program. I would encourage you to play around with these salesperson, warehouse, and office manager methods, classes, sorry. Add different methods or different attributes, play around with it, use it as a chance to explore how classes and objects work. You can also call other methods or supply different values within our main class here to just explore how all of these objects interact with the data that you supply and the way that you call the methods. Once you are satisfied that you understand how objects and methods work, you'll want to progress to completing your programming project for this module. And this is a great springboard for understanding how to set up your programming project. So lastly, if you have any questions, please email me. I'm happy to provide more information on this video. I'm happy to provide more information on the programming assignment if you're not sure of how to get started. I am here to help. I am here to answer questions. Please don't be afraid to reach out. And I hope that you found this video informative as our first video getting introduced into classes and objects. Thank you all for watching, and until next time.